Alright, this is exercise video 4-7. For this exercise we are going to grade stairs and a ramp with uniform slopes. So they give you the criteria for the stairs here, and they give you the criteria for the ramp. I'm going to move this so you can see the whole page now, but we'll refer back to this and I'll show you when we do. So this is a sidewalk. The only information they're giving you is top of step is 232.6 is the elevation of the top of step, and you remember this dashed line is the top of the step. It's not a riser, it is the back top of step. It's the where the expansion joint would be, where the step meets the sidewalk. So the other thing we know is the scale. So it's 1 inch equals 8 feet. So with our scale, we'll be able to tell some horizontal distances that we'll need to determine. So with that, let's get started. First thing we're going to have to do is draw what we know, and that is the stairs. So I'm going to move this because it doesn't fit on this page. So I want you to see, it tells you the riser height for the stairs is 6 inches and the tread length is 12 inches. The overall vertical elevation of the stairs is 5 feet. So vertically, the stairs are 5 feet, which means if we have a riser height of 6 inches, half a foot, and we have a vertical drop of 5 feet, how many steps do we need? Well, it's 5 feet, each one is 6 inches, so we would need 10 stairs. Right? Vertically, 10 stairs, half inch each riser equals 5 feet total vertical. So let's go ahead and draw that in. So this is 1/8 inch scale. This is where your stairs start. So let's draw in 10 steps. That'll be the first thing we do. So let's put my glasses on, and then we will draw in 10 steps. 1, 2, 3, 5, 6, 8, 9, 10. Do the same thing over here so I can draw the lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to connect those. And these are solid lines. These are actually the riser for the steps. So the steps have 6 inch risers. And remember that steps have a 2% wash or slope built into the tread. So that 6 inches is from the top of the step here to the bottom of this riser. That would be 6 inches from here, this dashed line, down to the bottom of this riser. From the bottom of this riser here to the bottom of this riser would be 6 inches. So let's draw this, finish drawing these in. And that should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times 6 inches equals 5 feet. So 10 times 6 inches equals 5 feet of vertical. So now we've got our stairs. And they tell us for the landings, provide 5-foot clear landings at the bottom and top of stairs only. So with that, from here, we got to go 5 feet for our landing. So that being the case, that's 5 feet right there. And I'm going to do 5 feet here. So I did those just so I could draw a line across, because we're going to have a ramp going this direction. And I just drew a light line because that's the ramp. What we've got stairs, so now we've got to go down this ramp, down this direction, and back over and end up at the bottom of the stairs with the ramp. So we're just making sure that there's 5 feet of clearance 5 feet for the landing up top. We won't actually draw a line here because this is a sidewalk, so the sidewalk, this will count as the landing right here. But we've got to draw in this horizontal line just as a guideline. So now there's that 5-foot ramp at the top, and then at the bottom we're going to have a 5-foot landing as well. But remember, this is the bottom step, and we have to have a handrail extension, correct? So we can't put the ramp right at the bottom and tie in at the bottom of the step. We got to tie in a foot away from the bottom of the step, this riser, so that we can do the handrail extension of a foot. So let's go ahead, show that handrail extension. I'm just putting the dots for guides, and so then this is my bottom ramp going like that. So that way the ramp will tie in here, and the railing will come down here, but the ramp will have 5 feet of clearance coming this direction, and that railing extension won't affect it. So we'll go ahead and make this ramp at the bottom 5 feet as well. So 5 feet and 5 feet. So we haven't done any calculations yet. We've just been kind of drawing in the information they've given us, right? So now up at the top here, remember this ramp is going downhill this way, come down this way, and then come back this way. Remember, at each ramp we also have to have the railing has to come up. We have to have a 12-inch or 1-foot railing extension at the top and the bottom of these ramps, just like we did on an earlier lesson. So let's draw those in. And we draw those in with the dashed line as well. And remember, that's for the handrail extension. And the handrail extensions, see this right here? Handrail extension slopes at 2% downhill. So this will go 2% here, and then it'll go into the ramp. And then you come down to the bottom of the ramp, and it levels out at 2% for a foot for the handrail at the bottom as well. So let's draw these two in. So all right, so those are our extensions right there, and then we've got one down here as well. Let's go ahead and draw our railings in. You can just draw your railings in so we know they're there. We won't forget about it. Just drawing in like a 1/2 foot on each side. Just putting it so it's parallel. So there's one there. And then I'm going to do another one over here. Where are my guides? So handrail goes to the top of the step, and then it extends for a foot below the bottom riser. And then this handrail will come down and extend a foot this way. And we talked about this in class last night, connecting these. You could connect these railings if you wanted. But either way is fine. I think it would look nice to connect the railings. But now we've got this information. What else do we need to do? What's the next step? Let's look at our steps here. So now we've got the landings at the top and the bottom. We need to determine the total height of the ramp. So to determine the total height of the ramp, we got to calculate the spot elevations for the top and the bottom of the landing, here and here. So in here, because the total slope, we got to calculate this spot of elevation down from here down to here, so we can determine what the total vertical drop of the ramp is going to be, and that's how we can determine how long this ramp needs to be. So the only thing we know here, we know the top of stairs is 232.6, and we know that this has a 2% slope this way, and it has a 2% slope this way. And the reason we know that is because right here it said stair landing slope at 2%. So there's our landing, 2%. And then it also says that these handrail extensions here and here are 2% as well, which is right here. Slope handrail extensions at 2%. So that's why we know that's 2%. So if this is 232.6, and this we know this is 5 feet, because we have 5 foot, you can either scale it off, but we drew that 5 feet over. So it's going uphill at 2% for 5 feet. What do we know? We know that we're trying to find the vertical rise, so vertical equals horizontal times slope. What's your horizontal? From there to there. Because this corner here, this is the top of step, so this entire line, this right here, is 232.6. So these corners here and here, they're 232.6. So what's 5 feet times 0.02? What does that equal? That at your calculator, it should equal 5 times 0.02 equals 0.1. So this is 0.1. So we just have to add 0.1 to this elevation to get that elevation, and that gives us 232.7. We just added 0.1 to that elevation to get this elevation. So now we need to calculate what this elevation is down here. To do that, we have to determine what this elevation is and then do the 2%. So this drops, actually, we're going to go, let's go to the bottom of the steps. So I'm going to write really small here, bottom of step. So this is 232.6. What is the bottom of step? What's it say? Our vertical, we've got 10 steps because our vertical elevation is 5 feet. So we drop 5 feet with the stairs. So if you drop 5 feet, you just subtract this 232.6, 232.6, and you just subtract the 5 feet, and that equals 227.6. So 227.6. That's 227.6. I just took 5 feet from this elevation, I got that elevation. Now that is the bottom of this riser, that solid line right there. So now we've got to go, we can calculate this corner. We could calculate to this corner if we wanted to, right? It's just 6 feet from here, because this is a 5 foot landing plus that 1 foot handrail extension. So if we just did 6 feet times 0.02, but let's get this corner here as well. So it's 1 foot away from the bottom of step, this riser, at a slope of 0.02. 1 times 0.02 is 0.02, right? So this drops from here to here, 0.02, so it's this 227.6 minus 0.02, 2% equals that 2, because that's just 1 times 0.02, and that equals, at that corner, 227.58. So I'm going to write it right here. 227.58, and that's that one. That corner is 227.58. And then this corner here, this is 5 feet away at 2%, which we said 5 times 0.02, right? We're getting the verticals 0.1, so it drops from here 0.1. So we just go this 227, actually that's right here, 227.6, and this time we just subtract 0.1, which is 5 feet at 2%. 5 feet at 2%. And that gives us, I'm going to erase this, don't need that there. So that gives us 0.1, so we subtract 0.1 and we get 227.48. So 227.58, 227.58 minus 0.1 equals 227.48. So now we can calculate what the vertical distance is, the drop of the ramp, because it's going to drop from here, 232.7, 232.7, and we're going to subtract this elevation from the bottom, so that's 227.48, and what's that equal? 232.7 minus 227.48 equals 5.22 feet. So from here the ramp drops all the way down to this point here, which is 5.22 feet. Alright, so that's the total height. But if you remember from our earlier lesson now, we're going to have a 2% slope from here to here. Then this slope going down your ramp that can be up to 0.833. Remember, 0.0833 or 8.33%. That's what the ADA, allowable maximum slope for your ramp. So it's obviously not going to be 2%, but we've got to subtract out this total distance. We've got to subtract out the 2 landings at 2%, right? And there's 2 landings. So each landing is 2%. So we're going 2 feet, 1 foot here, 1 foot here. So 2 times 0.02 equals 0.04. Right? So there's 2 feet because there's a foot there, at 2% equals that. So that is your extension. That's your handrail extensions. And then we've got 2, we're going to come down, and we've got to have, at the bottom, we've got to have a landing, so we can turn, then go down the ramp this way, another foot landing, and then turn and come this way. Those landings are 5 feet. Right here, let's see. Stair landing slope at 2%. Provide 5 foot clear landing at bottom and top of stairs. What does it say? Calculate slope handrails 2%. Calculate. I think the ramp, where does it say? It's going to be 5 feet because the landings are 5 feet. So right there, stair landings 5 feet. I don't see. Just provide a clear landing at bottom and top of stairs, but you also have to provide a landing at the slope at the bottom of the ramp where it turns, because remember, maximum length of a ramp is 30 feet, and this is going to be longer than 30 feet. You'll see that. So you have to provide a landing on a ramp every 30 feet at the max. The max distance is 30 feet. So we're going to have 2 landings because we got to come down, have a landing, turn, have a landing, turn. So that landing is 5 feet, and we've got 2 of them. So 5 feet twice, we've got 10 feet times 0.02. So 10 times 0.02 is 0.2. 0.2 feet. And that is the length of your landing. So that's your ramp landings, and this is your extension for your handrails. Write that so you can see. So we've got 2 of these handrail extensions, one there and one there, and we've got 2 ramps. Let me show you. Maybe this will be better. If I show you, if you remember, let me look. Right here. This is from in the book. I'm going to show you this just so you can hopefully see, we're doing our stairs. Here's our handrail extension. We're going to come down at a slope, turn, and this is our landing right here. And so that's 5 feet and 5 feet down here. 2 landings, 5 feet at 2% on this problem. So now we've got to subtract. So these two, the handrail and the landings, equals 0.24 total. I added those together, those two, and we've got to subtract this from this because this is our total rise, total vertical. We got to subtract these from that, and that'll give us our total vertical for the ramp itself, excluding the handrails and the landings. So let's go 5.22, and we'll subtract 0.24. That gives us 5.22 minus 0.24 equals 4.98, and that's your ramp vertical. So that's the total vertical drop of the ramp itself. So now the next step we're going to do, let me turn back here so that I stay on track. Alright, so now we've got 4.98. We're going to divide 4.98 by the maximum slope to find the minimum length of ramp needed, the minimum length. So that would be, I want to go off the page here, 4.98, and then they divide it by the maximum slope, because we're trying to get what the horizontal distance is, right? Horizontal, right here, horizontal equals vertical divided by slope. We're trying to find the horizontal distance of the ramp itself, excluding the landings and the extensions. So the slope, horizontal slope of the ramp is going to be the vertical distance of the ramp, which the vertical we said is 4.98. We're going to divide that by the slope. What slope are we going to use? We're going to use this slope here, the maximum allowable slope by ADA for ramps. That's where we get that number. So we divide it by 0.0833, and that equals 4.98 divided by 0.0833 equals 59.78 feet. That's how long the ramp needs to be. It's actually 59.783913. Again, we're just rounding to the nearest hundredth. So 59.78. Now we got to subtract the length of the stairs plus the handrails, because we know this ramp here, what this ramp's going to be. So we need a total length of 59.78. We're trying to figure out the length of these two ramps here. We got to subtract this ramp section, because it's the three. You basically have three sections of ramps: ramp, ramp, and ramp. Well, how do we figure this one? Well, we know this one here because we have 10 steps plus 1 foot of extension. So each one's a foot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 feet is what we've got from here to here. 11 feet horizontally, right? The stair treads are each a foot. So what we do is we subtract the length of the stairs and the handrails, which is basically going to here, 11 feet, subtract the 11 feet from the length. So this 59.78 that we figured out, 59.78, subtract 11 feet, and you get 59.78 minus 11 equals 48.78. 48.78 feet. That is the length of these two ramps here. We have an 11-foot ramp here, and then we have basically half of this here and half here to get the full vertical drop. So that's the total length of the two ramps here. So next, divide by 2 for each ramp, right? Because there's two ramps, one here and here. So I want to make sure I'm not going off the page. 48 0.78 divided by 2 equals, 24.39. 24.39. So each ramp would be 24.39, 24.39. This ramp here is 11 feet. Let's do round to the nearest whole number. So the nearest whole number is 25. So if we round to 25, instead of 24.39, we just round it to 25 feet. So we can go 25 feet, 11 feet, 25 feet. Next, we find the slope of the ramp. So one of the reasons you could do this 24.39, but it's easier. You want to tell the contractor to go 24.39, or do you just want to use 25 feet? What's easier to measure? 25 feet, and that also will make your slope slightly lower than 8.33. You know, if you have the option on a slope, you don't want to necessarily go to 8.33 because that's your maximum. And if you say go to 8.33, it's easy to go slightly over that. And if you go over that, you know, in the field when you're building it, if you go over that, then you're violating ADA regulations. So it's always better to err on the side of caution, go a little under that. So with that, we're going to use 25 feet, makes it a little bit longer, and will give us a little bit shallower slope. So let's figure out what the slope of the ramp is. The ramp is, we've got two ramps at 25 feet, right? Two at 25, and then we've got one ramp at 11 feet, this here. So it's you've got an 11-foot ramp, plus you've got a 25-foot ramp, plus a 25-foot ramp. That equals 61 feet, right? So does that make sense? We're drawing this ramp kind of like this one here. So we've got 25 feet, we've got 11 feet, and then another 25 feet back. So that's what we're drawing. So with that, 61 feet is the total length. So what we want to do is figure out our slope of these ramps. And what is slope? Slope equals, right, vertical divided by horizontal. So our vertical is, what do we say our vertical of the ramp was? Vertical is 4.98. 4.98. Right? And we've got to divide that by our horizontal, which we said is 61 feet. So divide that by 61. And what do you get? 4.98 divided by 61 equals 0.08116, and then it goes actually 393, but we round to the nearest hundredth, so this is 8.16%, right? So we don't need to go 8.164. We just round for our slopes to the nearest hundredth. So what we've got is a ramp that goes this direction, 8.16%, in this direction, 8.16%, and then we have two that are, they're both 25 feet, right? So remember, now let's draw it in. We're going to go 25 feet, but we're going 25. The ramp starts here. This is that handrail extension. We're going to start the ramp at that dashed line, go 25 feet, and then we're going to go another 5 feet, 1, 2, 3, 1, 2, 3, 4, 5, to here for our landing, right? We're going to come down and turn. Let's draw the same thing down here. We're going to come 25 feet, and then 3, 4, 5, right? 25, 1, 2, 3, 4, 5. So now we can draw these lines this way, and now you can draw a harder line, because these aren't guidelines. These are your actual So it's like this. Now let's darken them so you can see them. Draw these in. Another one here. Now we've got 25 feet. We've got 25 feet here, and we've got, oops, 11 feet here. 11 feet here, and it goes actually like this. I'll draw it like this so you guys can see it. Actually, from here to here, that's 5 feet. Then you've got 11 feet from here to here, and then from here to here is another 5 feet. Okay? So now that we've done that, let's go ahead and calculate. Remember, the slope is coming this way, right? The stairs are going this way. So we're going to have a 2% cross slope this way, which we happen to have right here, so that's good, and a 2% cross slope this way. And then this one, we have 8.16%. But this one we don't need a cross slope going this way, right? Because the slope is coming this direction, so no need for a cross slope. So now we just have to grade out these spot elevations at these corners, and we'll be done. So to do that, this is 232.7 right here. It's going 1 foot at 2%. Remember, these extensions are 2%. It's up there in your, right there, slope handrail extension at 2%. So that's where that comes from. So this is 1 foot at 2%. So 1 times 0.02 equals 0.02. So we've got to subtract 0.02 from this elevation. 232.7 minus 0.02 equals, right, because 1 foot, 2%, so that's 0.02, and that gives us 232.68 for this elevation right here. 232.68. That's that elevation. And then we're going, this is, we can take the same thing. We took 0.02. We have to take 0.02 away from this as well to get this corner, right? And that corner becomes 232.58. We just simply took 232.6, subtracted 0.02, that's how it drops, and then we get 232.58. Now we've got to get these elevations. At these corners, we're going 20, what's the vertical drop from here to here? By now, hopefully everyone's getting that, vertical simply equals horizontal times slope. And we know the horizontal is 25 feet from there to there, 25 feet, and we just multiply that by the slope, 8.16, which is, right, we got to write it out, 0.0816. And that equals 25 times 0.0816 equals 2.04. I'm going to write it right here, 2.04. There's a point right there. So 2.04. So we've got to subtract 2.04 from this elevation to get this one, and we can subtract 2.04 from this elevation to get this corner. So let's do that. This one here, 232.68 minus 2.04. 2.04 equals 232.68 minus 2.04 equals 230.64. So this elevation right here is 230.64, and then this elevation right here, same thing, you just subtract that same amount, that 2.04 from this, right? 232.58 minus this. Let's do that. 232.58 232.58 minus 2.04. 2.04 equals, uh-oh, hopefully, let's see, I lost my signal there for a second, but it looks like it's back, so hopefully this video is still going. Same thing, I was just saying we're going to subtract this amount here, 232.58, minus that 2.04, just like we did from here to here. We do the same thing from here to here. So let's go 232.58 minus 2.04 equals 230.54, right? So this is 230.54. So this was 2% drop from here to here. We did it, same thing. So you've got a 2% drop from this 230.64 to 230.54. You've got a little 2% drop, which this is 5 feet at 2%, and these elevations are going to be the same, right? It's the top of the slope. So this elevation is 230.54. Same elevation here and here. It's flat when you start the ramp. So if that is 2% from here to here at 5 feet distance, this is 10 feet, so this will go 1% and 1% equals a total of a 2% drop, gets you to this elevation. So let's figure out this one. What is this corner right here? It drops at 1%, right? So 1% and 1% over 10 feet is the same as 2% over 5 feet. So let's go 5 feet times 0.01. 5, let's clear 5 times 0.01 equals 0.05. So 5 times 0.01, 5 feet at 1% equals 0.05. And if we subtract 230.64, we subtract this 0.05 from that number, what do you get? We'll go 230.64 minus 0.05, 230.59. So this is 230.59. Now we've got 230.654 and 230.54. We're going to drop how far? Now instead of going 25 feet at 8.16%, we're going 11 feet at 8.16%. So we'll go ahead and write that right here. 11 feet times 0.0816 equals 11 times 0.0816 equals, it equals, it's long, so I'm going to do this, 0.8976. And what do? We round to the nearest hundredth, right? The nearest hundredth right here. We don't have to subtract this total amount, 8.8976 from this. Let's just round that to 0.9, right? 0.9, because it's 89. We round to the nearest hundredth. Well, that becomes 890. That's the nearest. So subtract this number, 230.54, minus 0.9. Let's do that. So this number, 230.54, and we subtract this 0.9, and we get 229.64. So this is 229.64, and this over here is the same. It's 229.64, right? Because there's no cross slope, so it just comes down even. Now we've got a 2% drop from here to here, right? 2% cross slope, 2% drop from here to here. So same thing, it's 5 feet at 2%. Did we write that down anywhere on here? 5 feet times 2%. Let's see. Oh, right here. 5, because vertical, we got to figure out what the vertical drop from here to here is. It's horizontal, 5 feet times the slope, 0.02 equals 0.1. So we simply subtract 0.1 from 229.64, and you get 229.54. Right? We just took 0.1 away from this number, and we got that number, 229.54. And if this drops 2%, 5 feet at 2%, then this is 10 feet. So this is, again, is at 1% and 1%. So this corner here is the same elevation as here. And if this is, where do we write that down? Right here, 5 feet at 1%, 0.05. So this corner here is the same number as this. So let's take 229.64, subtract this 0.05, and that equals 229.59. So this corner here is 229.59, that corner there. And this one, just because it's going to get messy, I won't write that number there, but it's the same. Those two are the same numbers. So now we've got to get down to these corners, and we can do that. We can either go from here at 8.1%, 8.16% downhill this way, or we could go from this corner and this corner, right? We know this corner is 227.48. We go uphill for 1 foot at 2%, right? It's either way. It's either going uphill 2% right here, or downhill this whole thing, 8.16. Let's do it both ways and see if it comes out. So 227.48, this would be going uphill 1 foot. So it's 1 foot times 0.02, which equals 0.02. So let's add 0.02 to that. We get 227.48 plus 0.02, and we get 227.50. We can put a 0 on this because we always nearest hundredth. 227.50. Now let's do it this way. So if we go from here to here, that's 8.16% for 25 feet. So that would be this calculation: vertical, horizontal times slope, horizontal, 25 times our slope, 0.0816. What does that equal? 25 times 0.0816 equals 2.04. Well, we've got that actually right here, 2.04. Subtract. So this is going same distance. We got to subtract this elevation here. We got to subtract 2.04. Same number here. So what's 229.54? 229.54 minus 2.04 equals 227.5. 227.5. Same number. We got the same number going both directions. So we know we did it correctly. So there you go. You have all your elevations. This one, same thing. You could do one. I'm not going to calculate this corner right here for you. You can do that. Just either go uphill, same what we just did, uphill at 2%, or downhill from here at 8.16. That'll give you that. So there you go. You've got it all graded out. The last thing you have to do is just drawing some railings, handrails. So I usually just draw them in about a ½ foot in. And we talked about in class maintaining, these are 5 feet wide and wanting to have 5 feet of clearance. We're not going to count the handrails as interfering with the clearance because they don't in the book. And if you were asking yourself that question, that's the answer. So we just go down, right? Now this is where I'm saying you could connect these railings together like that. Same thing up here. We'll draw on a railing here. And that railing could connect right here, right? You could connect those railings together. Then we've got a railing on this side. Runs down. Again, we're going to the end of the extension, and then it curves around like so. Curves around. Same thing down here. Goes to the end of the extension, curves around, and you've got another one right here. And it curves. So I'm going to draw. So there's you've got your stairs with your handrail on each side. You've got your ramp with your handrail on each side. And that is how you do this problem.